So welcome everyone to this NLP meetup, our second event in the series of our meetup events. Today we have two talks by Vincent and also by Stefan, who are already here with us. We have this survey going on, so now I have the last seconds to fill in where you're joining us from today. Anna will reveal the results in a second. Before that, let me quickly say something about the event and about the agenda today. So we have as first speaker Stefan, who is talking about asking politicians via neural search. And then as a second talk, about half an hour later, we will have Vincent talking about whether we can even trust labels. And each of the talks is about 20 minutes, and then there are 10 minutes after that for questions. And then, so in total, after 1 hour, we will have time for some social interaction, and today we will do that via breakout rooms here in Zoom. So you can just stay in the call, and then we will randomly split the number of attendees into separate rooms. Yeah, now before we get started with the first talk, maybe Anna, you can reveal now the results of our survey. So we have a nice overview of cities where you're joining us from.
So we have people from all across the world, from Romania, Pakistan, Barcelona, Berlin, of course, and from beer country, my favorite one. So if you want to have a beer now, grab your beer. That's the good thing about virtual events. You can eat and drink at the side. So yeah, welcome everyone. Great to have you here, and let's get started with the first talk.
Yeah, so I hand it over to Stefan. Then the stage is yours.
Yes, thank you. Okay, so let me get, yeah, wait, sorry, I have to kick you out from sharing. Okay, so yes, hey, my name is Stefan. I'm a senior data scientist at Deal. I actually had my last day at work today because I quit, and I will be a freelance data scientist now for the next 2 or 3 months. So really looking forward to that, and to celebrate that, I would like to present a little project that I've been working on the side as a hobby. So yeah, let's get started. I guess most of you know that the elections of the German Bundestag were just 1 month ago. So every time before elections like that, I always have this question of like, who should I vote for? Of course, you have like tendencies and history and so on, but like I always like reconsider and think, who should I support? And yeah, in this quest, there are usually, for me, like 4 main channels. One is the election program of the different parties. Then another one, just news outlets, so print, online, TV, and whatever. And yeah, also social media channels of the parties. But then in Germany, we also have this special thing, which some of you might know, which is called the Wahlomat. I know that some other countries also have something similar. So the Wahlomat is basically something that gives you statements like this one: NLP should be a school subject. And now you can say, I agree with this statement, I don't agree with this statement, or I'm neutral. Or you can also skip if you maybe don't understand the statement. So in the end, the Wahlomat will evaluate your like how you agreed or disagreed on statements with what the party said, and then give you a ranking. I actually really like it. I think it's pretty nice, but yeah, it has a couple of issues, and one of them, it's quite static, and it's also like you feel a bit disconnected from the individuals of the different parties, because it's just like on a party level and not on a personal level. So I was asking myself, why can't I just ask politicians directly? Of course, because I don't really know any politicians and don't have their phone number, and they're usually not as responsive on Twitter or Facebook. But I think there's a way how you can do it. You can with neural search. So first question, what is neural search? So the basic idea is, here's me, that's me having a question, and I'm stating this question to some kind of smart machine. And this smart machine has access to a store of documents, in this case statements, and it tries to figure out which of these statements actually answers my question. So you see it has found one, and now it retrieves this statement to me. So I have asked a question in natural language, and I have gotten an answer in form of a statement here. So the question is like, why would you use neural search and not just keyword search? Because we're all pretty much used to entering keywords to get the information that we're actually interested in. Let me explain this with a little example. So let's say the question that I want to answer for myself is, when should Germany be CO2 neutral? So the keywords that I might use are Germany, CO2, and neutral. And let's say one correct answer of this would be Germany has to be carbon neutral by 2040. Germany is in there, neutral is in there, but CO2 is not in there because there's carbon, which is a synonym of CO2. So with keyword-based search, I wouldn't have found this, most likely. Let's look at another example. Here I actually have an answer that doesn't really answer the question. Germany needs to put in more effort to become CO2 neutral. So it's related, it's the same, it's the topic, but it doesn't answer the question of when it should do this. So in this case, actually, all keywords are matched. So you see in the first example, I wouldn't get the right answer. In the second example, I would get an answer, but it's not the right one. So you see that keyword-based search is widely used, but it has some weaknesses. Neural search in that sense is a little bit better because it understands synonyms. It also understands interactions between words. So it kind of understands also understands context. It understands like what a question looks like, what an answer looks like. So it has some upsides. So now that we have all agreed on that we should go with neural search and not keyword-based search, I would like to talk a little bit about how neural search system looks like. But before I do that, I want to do a little bit of advertising for not because I get paid by any of these companies, but just because I found, for me, it was such a game changer when I discovered these two frameworks. So the first one is Haystack. It's actually by the organizer of this event, DeepSet. It's just a really amazing framework that enables you to build neural search systems at scale, has all the components. Also, DeepSet has a lot of data sets and pre-trained models. And like really, while I was working on this project, there were like new releases constantly, which really helped so much. Like one of them was a German question answering data set, which was a real game changer. So the other one is Transformers by Hugging Face, which actually gives you a really easy way to like work with transformer models, which you might know by the name of GPT-3 or BERT or the like. And it works quite well with Haystack together. So let's look at the components of a neural search system. The very first one is a document store. So this is basically the place where I can store all my, in my case, statements of politicians, and that has all kinds of methods that help me to filter and retrieve those documents. The second one is the retriever, and the job of a retriever is to narrow down the scope of the search. So the document store can hold like thousands, tens of thousands, or even more documents. And the job of the retriever is to give me the n most likely documents that would answer my question. So the retriever retrieves these documents, and then it hands it over to the ranker. The ranker is much slower than the retriever, but it's also much better at identifying documents that answer a question. So the job of this is basically given a pair of a question and a document to predict if this document answers the question. So if everything goes well, this will actually give me the documents that answer my question. It can be 0 documents, it can be multiple or 1. So what I need is I need a collection of statements that are potential answers, and I went to Twitter for this. The reason for this is like there are a couple of upsides. When you look at Twitter as a data set for this project, the first one is tweets are pretty short, so they can be seen as kind of a statement. You know, like people that tweet need to make their tweets kind of snappy and like get to the point, which is nice. And it's also like performance-wise, it's a bit nicer if tweets are shorter. And Their Twitter is pretty widely used by German politicians, not so much by Angela Merkel, but she wasn't really so relevant for this project anymore. But like everyone, almost every German politician that is a little bit more well-known uses Twitter nowadays. And it has a pretty good API, which is handy because it's very easy to retrieve the data. The limits are quite friendly. So yeah, that's really nice. It has a downside. It has a couple of downsides, but for me, the major one was that the text is actually quite messy. So tweets are not necessarily natural language. They're like close to natural language, but they have hashtags and ad mentions and URLs and emojis. So yeah, that's definitely the challenge. So I needed to normalize the text a little bit. So if you look at something like at CDU Merkel, which is the account of Angela Merkel, I want to normalize this to Angela Merkel. And you can do this actually with the help of the Twitter API, because you know that CDU Merkel, the actual name is Angela Merkel. So this can be automatically done. And then I also normalize some emojis that are were occurring more often. So like the German flag to Germany, Deutschland. And then also I would remove all like hashtags and URLs, and that makes it like still not as much natural language as you might have in a book, but still like pretty close to it. So yeah, my corpus of tweets consisted of tweets from the 6 major parties and 18 most important politicians. Yeah, I used all tweets since the beginning of 2020, and in total, this was like mid-August. There were a couple more new ones now. Was around 15,400 tweets. So the retriever and ranker were pre-trained and trained on test sets that were based on Wikipedia, but the data that I have here now is a little bit different. So I definitely wanted to, first of all, test and understand how my system was working, and as well as fine-tune it a little more. So I was working on train and test set, and to understand how I did this, it makes sense to look at the data labeling process. So let's get back to this example that I had in the beginning. Let's say I have a tweet, which is Germany has to be carbon neutral by 2040. What I have to create now is a positive example. That means a question that is answered by this tweet. But what I also need is, I need a negative example, or I need, ideally I have a couple of these, that is not answered by the tweet, but it's still close to it. Because if it's something completely random, like will it rain tomorrow, then the model doesn't really learn anything from it. And it's also doesn't make any sense to evaluate a model based on this. So if I ask a question like, what should Germany do to become CO2 neutral? It is related, but it's not answered by the tweet. So this would be a good negative example, so to speak. Yeah, I have to say that labeling, doing this is actually quite labor intense and a little bit painful, to be honest. So my train and test sets were not that huge. In total, I had 525 tweets and 144 questions. There are some questions that are questions can be answered by more than one tweet. That's the reason you have more tweets than questions here. And I split that up to 420 tweets and 150 questions for train, and then 105 tweets and 29 questions for tests. So not huge, but still something to get an indication of how I'm doing. Yeah. Before we get to the fine-tuning, let's first look at how you would evaluate such neural search system. So this would be the happy path. You have a document which answers the question in the document store. The retriever finds it alongside of other documents which don't answer the question. And then the ranker correctly identifies this document. But let's say the ranker could also be wrong and pick one of the documents that don't actually answer the question. So have a false positive. Or the retriever could fail to retrieve the document that that answers the question. So in that case, the ranker can't really do anything. I mean, ideally, the ranker right now wouldn't output any answer. Yeah, so the metrics that you would use here are for the retriever, actually the top N recall. That means the recall that you have on the top N documents. So let's say I look at the top 5 documents that the retriever gives me is the document that answers the question within these 5 documents. For the ranker, it's a bit more standard, more straightforward, because the ranker is a binary classifier. You can use all kinds of metrics, recall, precision, MCC. I'm using F1 score to evaluate this here. So yeah, let's look at the results. The top five recall for the retriever before fine tuning was 0.52. And I mean, like you have to understand, if I take top 5 or top 10, like this obviously has an impact on the recall. So this is more like a stick in the mud. So yeah, before 0.52 and after fine tuning, this went up to 0.65. So actually quite an improvement. And for the ranker, it's a one score of 0.69 before fine tuning, and after fine tuning 0.85. I mean, as said, the test set is not really big, so it's a bit hard to say what the actual values would be, but this gives at least an indication that it would make a lot of sense actually to label more data and to use more for fine tuning. Yeah. So now that I've talked about this a lot, I would actually like to show you the web app that I built based on this. So wait a second. Yeah. So here's the German translation. It's automatically English translation. It's automatically translated, so it's not fully functional, but and I'm not really a front end developer, so I hope you're not ashamed or insulted by the design. Yes, so what I have actually two ways how you can interact with this website. One is you have questions that are pre-existing, so every question that someone asks will get stored in a database. And let's look at this. Does it actually do it? Yeah. So every question that someone asks gets stored in the database, and you can look through these questions, which is quite nice, because what I realized is that many people don't really have a question in mind when they land on this page. They are there and they don't really know what they want to know. And yeah, so this is a really good way how you can start your interaction. So I don't know, like you see some things where people like don't have like super proper spelling, or you also see sometimes that people still sometimes try to use keywords, but let's say should the minimum wage be increased? I click on this, and now what I see is I see my question, and this is basically, these are the answers grouped by party. So you see the Green Party, you have one candidate, Annalena Baerbock, and she talks about that we need fair wages all over Germany and equal wages in East and West. And you could click on this link. It doesn't really work with the English translation, but normally when you click on this link, you get to the Twitter page. Yes, and yeah, then you have all your other parties. You can also ask a question. I mean, I can show it to you in the German version. So I will ask something like, should Germany do more against climate change? So it can take a little bit. So if you test the website, you said it can take a little bit because it's serverless, and it can take a little bit to cold start this. And this is now really created an actual request to the model. So what happened before is I have the question stored, I have the answer stored. That's why it's, if you click on the existing questions, it's really, really fast. Here it normally takes 10 seconds. If it has to do a cold start, it takes like 20 or 20 something. Could be solved with a better machine, but that would be more expensive. Yes, okay. Now there's nothing else to do but wait for the answer. And yeah. There it is. Yeah, now I can also show you. I can click on this. I can click on this link. It guides to Twitter. And what I actually like about it is that you don't only get the answer. You also get interactions with this tweet, and you can see around this topic that interests you what other people thought about it. Yeah. So that is basically it.
Okay, then thank you for your presentation. Especially the last feature I really liked. Let's see whether there are some questions that came up. You can either post your question in the chat, or you can also unmute yourself and just ask. And if you write down the question in the chat, I will be happy to read it out.
I have a question. Thank you very much, Stefan. I have a question to the negative. You said you wrote the negative samples, and I would be interested on what was the proportion between positive and negative samples, and if it was uneven, so not 50-50, do you know how this would, what effect this would have to the model?
I think it was a little bit less negative than positive, to be honest, but I can't exactly tell you. I think also it's not only a case of like how many, it's also a case of how good, you know, as said, you know, the closer it is to actually being answered by a tweet, the better it is for the model, I would say. So, but it's a little bit hand wavy, you know, like I didn't really run a lot of experiments on this. Yeah, it's actually, I would say it's almost like a research topic to figure this out.
Okay, yeah. And what was your technique on writing these negatives? Did you have a systematic system, or did you just do it intuitively?
So, I mean, the thing that I try to do is, because it's really important that you don't just paraphrase what's there, right? So that you actually try to use different vocabulary, that you don't always repeat the same type of questions. And I mean, that's also what makes it so tedious and makes it so, you know, like time consuming, because if you just copy paste and change one word, for example, it doesn't really give the model a lot to learn from. And it also might, like, you know, make your metrics not very, you know, they don't tell you a lot if this is bad. So yeah, I really actually try to like change as many words as possible, change the way the questions are asked. So in that sense, my system was trying not to have too much of a system, you know, if that makes sense, like not too much of a template of questions that I would ask.
Okay, cool. And one last question. Why did you think about choosing natural negative examples from the data set? Or did you do something like that?
I actually did. So I did something, I mean, it could call it active learning. So what I tried is before fine tuning, I also used the model that was pre-trained and like classified, like took the questions and then classified tweets and then would in this case, just hand label, does this answer or does this not answer the question? So, but I found actually that these examples were not great. So there were, like, I would say you can create better negative examples if you hand label things.
Good. Thank you.
So let me jump in and read out a few questions. So I saw two questions that are more about the future directions of your work, maybe. So one is about automating question generation and trying to use sequence-to-sequence models to automatically come up with questions that can be answered based on your data set. And the other question is about personalization of your search engine. So maybe you've thought about these two topics or have any immediate thoughts?
Which question is it? Like the first one?
The first one is, did you try automating question generation with sequence-to-sequence models from Carlos? And the other one is the most recent one.
Oh, no, actually I didn't. I mean, it might, like, intuitively, if you use a different model to do this, then the model that is used to do the classification, it might actually do something. I probably, like, definitely not as good, or it will not bring you as far as like really putting in a lot of effort and labeling your own data set. But yeah, but no, I actually didn't test that.
And the other question is about personalization. So also thinking a bit towards the future implementation, future ideas.
Personalization in what way?
So I think that different users using your tool get different answers, basically, different results. Maybe you're more interested into certain politicians, that could be, right? Filtering by politicians. If you already know that this user is more interested in certain parties, for example.
Yeah, I think that's actually super important. Actually, that's super important. I also thought about things like where you could follow questions or topics or like these kind of things and get updates once. I mean, you can either get an update once I get a better model and I get more answers that I actually find, or because you have new tweets. Yeah, that would definitely be direction.
And maybe related to this, Johannes asked about how you chose these 18 most popular politicians.
It was a mix of just looking into what are the top candidates of the parties, and to be honest, a little bit also how active they are on Twitter. And I have to admit that this is one thing that, like, if you really want to make a tool like that, that's supposed to be like for the broader public, it's a super sensitive topic, because obviously you have a huge bias by picking like which politicians you pick, and obviously also how you select the training data and how you label the data. So I would say it's a very delicate topic, and I try to be as neutral as possible. But I'm sure I would still fail the test if someone would like really look very close into this, to be honest. Yeah, and I mean, then there are things like Habeck from the Green Party, who's like the second runner-up for the Green Party. He doesn't use Twitter since 2019 because he somehow doesn't like it anymore, and that makes it very hard, right? So I think if you want to make something like that production ready, you need more data sources to make it a little bit more unbiased by the channel itself.
Maybe related to this, Malte posted as the first one, I think, the question, what was the hardest part of your project, the most difficult one, the most painful one?
The most painful one, like the 2 days of data labeling were tough for some reason. I got physical pain by like always clicking the next button. You know, I was using this annotation tool of Haystack, which is quite nice, but it's just like, yeah, but that was one part. I think, for me personally, I think it's just the scope that you have to do everything yourself. You know, like you have to be a product manager, you have to do data labeling, you have to work on the modeling part, you have to get the data, you have to do the front end, which I really suck at. You have to do the architecture, like all of this together was just, and then having a deadline because I wanted to be done before the Bundestagswahl. I think that was a bit too much at some point. So yeah, what was most painful? I would say the pressure that I put myself on. Yeah.
Okay. Yeah. So what about implementation wise difficulties? So one question here was about the storage, like the document store. So that's obviously an implementation detail, but maybe more generally speaking, like choosing the different parts of your pipeline, including the document store, the storage, was that also difficult, or was it easier than you thought first?
I mean, with Haystack, it was definitely easy. In the beginning, I tried to do it without Haystack, and that didn't go so well. So yeah, that I would say the hardest part for me was really to get everything into the cloud and making it work, you know, like smooth. And also one topic is that it has to be quick enough, right? So I mean, you already saw that it takes like, I think it takes like 12 seconds for the endpoint to start, and then, you know, another, like if you send a request, it's 10 seconds. So this is already like borderline, yeah, kind of like getting it to be not too slow, but at the same time still having high enough performance. This was definitely a little bit difficult. In the beginning, I was not using, right now I'm using a dense passage retriever. In the beginning, I was just using, what is like BM25, elastic search. That was, the retrieving part was super quick, but the results were just like much worse. So, I mean, like, it was all it was kind of like, you know, like learning on the go, and then always having to make sometimes bigger changes than I expected to the whole thing, just to get like some improvement, which a normal user wouldn't see that much. Yeah.
I think
But
there's
it's fun. I mean, like if you do the project for fun, it's really nice because you learn a lot of things and you also see firsthand what's happening and what changes how much and why some things make sense. So
yeah, so there's one more question regarding deployment, but I think maybe you can later on then go through the messages in the chat and maybe also reply there, right? Because we're kind of running out of time and need to get ready for the second talk in a minute. Maybe as a last question, actually the next speaker, Vincent, asked about how robust your tool is against typos. I mean, obviously we could now all go to our web browser and try that out, but maybe you can give some intuition on how robust your model is there and how it works with words it has never seen before, maybe.
I mean, so because it's using word piece tokenizer, it can also work on words that it hasn't seen before, right? Because it works on sub words and like so on and so forth. So I still found it to be actually pretty sensitive to typos. And even, it's funny, but like even things like, starting the first word lowercase, like all of this would tick it off a little bit. I did some experiments, not exhaustively, but I actually saw that it's not super robust to these kind of things. And that I think is a big challenge because people are used to really just like type like almost blindly, especially on the mobile phone. And like also with Google, I type like the weirdest queries into Google and expect Google to figure out what I want. And yeah, like here, this doesn't work. I know that Haystack has something where you can actually at least identify if a query is keyword based and not a question. So you could have that kind of classifier in the beginning to help people get on the right track. But yeah, I've seen so many weird questions that the models couldn't deal with, and with some changes it would. So it's not extremely robust to that. Yeah. Okay, cool. Yeah, so maybe you can go through the questions in the chat and answer some more than there. And for time reasons, we now move to our second talk, our second speaker, Vincent. And from trusting or questioning politicians, we move to trusting labels. So Vincent, yeah, the stage is yours. Maybe you're on mute still, but we can already see your screen, so that works.
There we go. Okay, that
Yes.
was the button. All right, so just to check the AV one more time. If I were to do this, people can see me doodle.
Yes.
Just say regular. All right, everything works. So hi everyone. My name is Vincent. I am a research advocate at Rasa. Typically, a lot of what I do means that we have a research team and we have our team of developers, like our general community. And at Rasa, we like to make chatbots. For those of you that didn't know, we are an open source Python solution for chatbots. But my role within the organization is that I'm kind of the interface between the research team and the sort of more global community, which means that I tend to do a lot of research on non-English. I try to make sure that Rasa works also in the non-English setting. What that also entails is outside of Rasa, I do also have a lot of side projects, Fair Learn, fairness pipelines for scikit-learn. In case you're interested, I've done some collaboration there. You might have seen some of my stuff on YouTube as well. Ask me anything about this later. But the main thing that I do as a developer research advocate at Rasa is I educate people. I try to warn people against hype. I try to really explain what it takes to actually build a proper virtual assistant. And a lot of that boils down to this one Venn diagram. Like if I really have to explain how you do machine learning, it usually boils down to this. There's a stuff that people like to optimize with a machine learning pipeline. That's represented by this little circle over here. Then there's typically also the stuff that users care about, which is this circle. Oh, oops, my bad. Which is this little circle over here. And the hard part of machine learning is making sure the overlap between these two concerns is actually big. There's a lot of machine learning pipelines that give you the best accuracy score, but it's not necessarily the case that's in any way reflective of what happens in reality. And there's a bunch of reasons for this, a couple of really good ones. But recently, a big concern on my end is that it's due to bad labels. So just to give a quick example, if you go to this website called labelerrors.com, you can have a look at what ImageNet contains. And according to the ImageNet data set, like the test set in there, let's see if there's a couple of good examples. Apparently the scorpion is a tick, according to the ImageNet data set, just a mistake that's in there. And apparently this scorpion is a southern black widow, and apparently this is a red panda. And this is a tub, apparently. Now, this is just one of these data sets, right? But it's not just ImageNet. You can also check out MNIST, which is really like the standard data set, but there's some mistakes in there as well. And the same thing goes with the Amazon sentiment data set. And this is kind of concerning, right? So if we are convincing ourselves that we have this state-of-the-art approach to tackle this NLP problem, then at least the way that we measure whether or not something is state-of-the-art should be accurate. And for years, people have been blindly trusting these data sets. And more, I've been trying to figure out if this is something we should be concerned with. And my conclusion is we definitely should. This website is part of a paper. You can read it. And apparently 10% of quick draw is wrong. Supposedly, if memory serves, the Amazon data set has like 3% label error. So if you're state of the art, then that might just be because you're overfitting on bad labels. And that's like a very scary conclusion. So what I ended up doing as an exercise for myself is I started, figuring out like what are some tricks to find bad labels, like what are some good sanity checks to go and find them. Then I saw this announcement that Spacey models could now be hosted on Hugging Face, and I saw that they were using this sentiment data set for that, known as the Google Emotions data set. And Google spent a fair amount of effort, I imagine me, on getting this data set out there. There's this one paper that you can get, and you can read what they've done. And it's Reddit that they've copied. And the idea is that when there's a sentence like, I'm not even sure what that is, why do people hate it? Then there's an emotion that's attached to that. It's kind of like a tagging system. So it's not classification in that sense. It's not like there's a mutually exclusive set of labels. You can have a sentence that has more than one emotion attached, and the goal of this of us is to actually find what emotion that is. I think they had like 70 people label this. They made sure that 3 to 5 people saw each and every single example. So, proper effort was spent in getting this data set out there. So I was wondering, how easy could it be to find label errors in this thing, right? Like Google wrote a paper about this. Surely this shouldn't be hard. This shouldn't be easy. This should be pretty hard. So let's have a go. What I'm showing you here is a Jupyter notebook, and I'll just quickly kind of go over the code, show you what it does. And if there's extra time later, we can fiddle around a little bit. But what I've got here is a part of the emotions data set. And the idea behind the data set is that we have a text, we have an ID for every single row in the data, some author, some subreddit, but we also have whether or not a certain emotion was in there. For example, joy or fear or gratitude. Now, this is Reddit, so the odds of me generating slander by accident is here, which I would kind of like to warn the audience for. But I figured, as an example, let's just go for the label excitement. Let's pretend that that's the one label that we're interested in. So what I can do is I can just say, hey, let's sample a little bit from the data set. And we basically get this one little text, and then we get whether or not it was excitement. So you can sort of do this a couple of times. And one thing you kind of learn is that most of the time it's not about excitement. Like a very small portion of these labels are actually about excitement according to the label. But then one of the things you start thinking about is like, okay, are all of these labels accurate? What can we do? So one thing that you could do just from the get-go is you're just going to try to make the simplest model out there. You're going to make a scikit-learn pipeline where you're just using a count vectorizer and a logistic regression. And effectively what this count vectorizer is doing is it's basically saying every single word is going to get mapped to like a sparse array. Everything in the array is 0, except for the place where the word matches, then we have a 1. I'm just going to pass this array with many zeros and a couple of ones to a logistic regression, which is like the simplest neural network that you can think of. But the hope is like we have a basic model, and then we might be able to use this model to find bad labels. So I go ahead and I train this model. It takes about 3 seconds, 70,000 rows. It's not super huge, but it's relatively big, right? Well, the first thing that you can then do, because it's a binary classification, you can kind of say, well, there's going to be moments where the model is relatively sure that we're in one class or the other, but it's also going to be moments where it's relatively unsure. And whenever you call predict proba on a scikit-learn model, it's not exactly model confidence, it's not exactly a probability, but it's kind of like it. So what you can do is you can basically ask scikit-learn, could you please retrieve me all the rows where these probability values are close to 50-50? And when you do that, then that's adorable as F. That's not excitement. But in this case, you could kind of wonder, well, it's slang language, but you could hear a little bit of excitement in there. But then you also got this example that says, oh my God, those tiny shoes, desire to boop snoot intensifies, which, is definitely online teenage language. But that's excitement. Like someone's really excited, probably because there's a picture of a cat somewhere. So this is wrong, I would argue. And I'm only looking at like the top 7 rows. I could be looking at way more. But this already is kind of a little trick where you can make a short list, where you can also kind of spot that some of the labels might just be a little bit off. There is also a more powerful technique that you could try, though. And this is the technique that I tend to use most of the time. This trick works fairly well in most cases. What you can do is you can make this one function that tries to fetch the confidence of the correct class. Now, the idea here is, let's say that the actual true label, according to the data set, is that there is excitement. So the true label, according to my data, is that should be a 1. If my model then says, well, the confidence that I have for that label is like really, really freaking low, then you can argue, hey, there's an instance here where my model disagrees with reality. Like the actual label doesn't resemble what my model thinks is happening at all. That's different from when the model's unsure about something, but this, I would argue, is a very strong signal that something might be up. So what you can then do is you can say, well, let's reuse the same model, but now do this query inside of scikit-learn, etc. And then the first example here that's not about excitement is the sentence that reads, I'm inexplicably excited by name. I get so excited by how he curl passes. According to the data set, that's not excitement. The thing is, like, I'm not really trying, right? This is not like I've done a huge model or anything. I've just done this one little trick, but this is just a bad label. And so are the next sentences, like, oh my God, this is so amazing. Yeah, okay, that's excitement. Sounds like a fun game. Our home game here, it's fun, but not very exciting. Okay, so this one I do agree with. And, we should actually go through all of these examples. This is just like a short list. But the fact that this is in the top 3 also makes me believe that, yeah, we have to be really careful trusting these labels, because this is just a simple example, right? Now, the funny thing here, when you're doing this tactic, which is something I'm trying to figure out why and how, but one thing that I find pretty interesting is that the results that you get back here do really depend on the model that you're training, right? So right now I'm using a count vectorizer with logistic regression, and that's giving me some of these examples below here. Now, if you think about it, that's kind of a high bias model. It's on the spectrum of high bias, high variance, it's not in the middle. It's definitely on the high bias kind of angle. And that makes sense, but there are some other high bias kinds of models that we can also think of that might be working here. One of the ways that you might be able to do that is to say, well, let's not train on just this one data set. Let's use embeddings instead. Now, these are, of course, Reddit sentences, so we should assume bad spelling. So probably something like fast text or byte pair embeddings would work quite well here. So what I'm doing here is I'm doing the exact same trick. I wrote this library called What Lies. It's a tool to figure out what lies in word embeddings. And one of the things that it provides is just these scikit-learn compatible word embedding classes. So if you just want to pluck an English or Spanish or whatever word embedding from whatever backend, this is a very convenient way to do that. And when you do this and you run the same trick, you kind of get different results, which is pretty interesting. Because right now we are being heavily biased by what the word embedding thinks is excitement. And now I'm getting these examples of wow, happy birthday, basically these really, really short sentences, which makes sense because word embeddings don't necessarily aggregate well. But again, also here I can say like happy birthday exclamation point. That's excitement, right? Like this is a failure. We're dealing with bad labels here. Another thing that you could do in these situations, right, I'm just showing you a couple of examples, but a couple of other ideas that we could do now is we could say, well, we kind of have model 1 and we have model 2. And right now what we're doing is we're saying, well, we're looking for moments when they don't necessarily reflect reality as in the label that we see, which is pretty good. But we can also say, well, it might also just be interesting when model 1 doesn't agree with model 2. If we have one model that's like a logistic regression, just count vectorizer, and we have another model that's, using a word embedding quite heavily, then I could argue that both of these systems might be accurate, but because of very fundamentally different reasons. The mechanic that's making the prediction is different. So therefore, when these two models disagree, since both models presumably do something that's sensible, whenever there's disagreement between models, that's also something that we can use to make a short list. Other tactics that we might be able to use are just outliers. Whatever outlier system you like, you can try that out on the data set. And these outliers should also be something that's interesting to just double check. But this whole idea of using machine learning models to double check our original data seems to be something that generally works. So far, it seems to work quite well for high bias models, though. Having said all of that, there's also another trick that you could do. And this trick revolves around confusion matrices. So let's say that we have a confusion matrix. So this is like true labels. And this is what we predict. I always mix those two up. But here's the general gist. Let's say that we have label 0, label 1. And for some reason, it seems that our system has like a 15% error in this corner. And one way of interpreting that result is that we could say, well, if our model predicts a 0, then there's a 15% chance it's actually a 1. So it might be because of ambiguity in our labels. Might be. Not certainty, but it might be. So how about we do the following? We take the probability values where we say something like, well, we are predicting a 1. That's a given. So we're predicting a 0. We're definitely predicting in this row. But then we're going to sort based on the proba value that the model gives. And we're just going to have a look at the top 15%. Again, because the idea is that the confusion matrix is telling us that these might be the candidates that are the most ambiguous. This idea is basically what the CleanLab library does. So the label errors website that I just showed you, the creators of that website also made a somewhat general Python package that helps you find bad labels. The Python package is called CleanLab, and it's this mechanic that underlies. You're able to give it a general model, and it's using this confusion matrix trick to also make a short list of examples you might want to just double check and have a look at. And when you use this library, then you're also getting the I'm inexplicably excited by name example. So the question kind of is like, what should we think of this, right? So this is just a data set, sure. And I don't want to suggest that what I've done here is like rocket science. It was a little bit of effort, but it's not necessarily big rocket science. But one thing that it really does demonstrate is a concern. I don't think we should assume something is state of the art just because a paper says so, because that one little summary statistic assumes that all the labels that we have at our disposal are correct. And maybe before we even do something like this in practice, this is a really good exercise to just do. Like we should just have tools at our disposal to first just check if our labels are accurate to start with. Because, if we don't do that one basic step, then you hit this issue. Then you hit this really uncomfortable situation where you're definitely optimizing something, but it might just be something that's completely unrelated to what your users are just interested in. And that's, I think, a very dangerous scenario to be in. So if you're interested in this, I have a full blog post on my blog over at Koning.io, where I basically step-by-step explain this, and I give some more hilarious examples of stuff that's wrong with this data set. So if you're interested to learn more, we have that. Also, if you're a Rasa user, I have this library called Typo. Originally, it was meant for misspellings, but it's basically a suite of tools for data quality inside of Rasa. And one of the tools that I made here is basically what I've shown you here today, where you can take your Rasa data set and you can just run this tool against it to see if you can find some bad labels in the data that you've given Rasa. Basically, what it's able to do is it takes the pre-trained Rasa pipeline that you've made for your virtual assistant. It's able to compare that to your natural language data, and then it will just give you a short list of stuff you just go ahead and check. And if that wasn't enough, what I also have is I maintain this project called calmcode.io, and there's a full course on how to find bad labels there. If you want to do the stuff that I just explained to you, like in a little bit more depth, a little bit more slowly, it's free resource. Definitely go and check that out as well. And if there's time, one thing that we could do is we could maybe have a look at another emotion, but I don't know how much time I have at the moment.
Yeah, I think we have about like 2 more minutes for your talk. Yeah.
Okay, so so then from the audience, what emotion do we want to see that's not about excitement?
Somebody wrote anger and fear
Okay, so,
in the chat.
So one thing about anger, I am willing to do anger, but we are asking Reddit. So there is going to be slander and stuff, right? Like I do genuinely want to warn people for this, because there is some horrible stuff in here. Like, not a joke. There is some really cruel sense of humor. But okay, anger also kind of imbalanced, right? Again, I'll train a new pipeline. Let's fit. This one should take about 3 seconds. There you go. We can do the model uncertainty trick again. Let's see what we get. Yeah, so this is the horrible stuff I wanted to warn you. Stuff like I want to die, right? Like, okay, genuinely horrible stuff. But you also get this sort of thing, like whenever the word hate appears, then this model's kind of sensitive for that, right? The appearance of a word is something that this approach really suffers from. This word obviously triggers the model as well, I think. Let's just try this one model trick as well. This one takes a while. Yeah, okay. So basically what we've built here is the F word detector. If I, yeah, Reddit. Yeah. But anyway, I do think that this is anger, right? And still bad labeled. I'm sad to say that this is why I don't hang out on Reddit anymore. But this is the approach in essence. Let's try let's try neutral. Let's try love. Let me try that one. Just to end on a more positive note. Okay, so love this. So happy for the both of you is not about love, according to the data set. I mean, this is crazy, right? They published a paper on this. Like, this is bad labels are a problem. That's the gist of my story here.
Okay, then I say thank you for your presentation, and we open the floor for questions. Again, either in a chat form or you can just speak up. There's already one first question in the chat, I think. Yeah. So if you want, I can read it out. If it makes it easier.
Have you thought about using the Snorkel library to write a bunch of weak inverse labeling functions? So the thing with Snorkel is I get what they're trying to do, but part of me just likes having not a weakly labeling function, but just a single labeling function, just because I find it a little bit easier to reason about. Snorkel has an interesting idea. Like, I really think that they've done something clever, but I prefer having like an actual label of which I'm actually sure whether or not it's false and giving that to the machine learning algorithm, as opposed to having like a rule that might apply sometimes and hoping that the machine learning algorithm is able to figure that out. So I've not tried Snorkel for this reason. So another question is, do you presume that these errors are rather random or systematic? That's a really good question. So the paper sheds a little bit of light on that. So they don't give full details, but later on in the paper, there is this notion. So they give a couple of details about the group that's been labeling. And I believe these were annotators. I believe it was a group who lived in India and had English as a second language. And the thing that I do think is fair to mention about that is there is this cultural aspect to detecting emotion, right? And I also would like to admit that I think if I on my own were to label this data set, there's going to be examples that are kind of could go either way in terms of, is this really an emotion? Because sarcasm is really hard to detect as well. So I think it's fair to say that it might just be not completely random, but certainly systematic. There's definitely evidence of that, I think. But I'm also sure that randomness has a role to play here as well. If you've been labeling for an hour, my recommendation is just to quit, but I can imagine not everyone does that. So some of this might also just be because people are tired, which would also presume maybe some of this bad labels is random. And
there was another question. What do you think can be done in the labeling process, tooling to avoid bad labels in the first place?
This, just this, just after like label for a bit, and then a week later, double check if the model that is trained on that is picking up the patterns that you're interested in. Just always be skeptical. And also the thing that I would like to remind people of, if you're a data scientist and it's your responsibility, so the machine learning output, if that's your responsibility, then it should also be your responsibility to consider what goes into the model. I could definitely argue that if I have a random forest or a logistic regression, then the output of both algorithms is more determined by the data that I feed them than the algorithms themselves. So if you want to prevent this, you should just do this exercise of trying to find bad labels and not trust data. That's, I think, it's an attitude thing in that sense, I think. So you have to really care about data quality. That's the best thing you should do.
So if I imagine I write a paper, maybe I want to publish a data set that I annotated myself or with a team. Is there a way how can I report in my paper that I believe I haven't made such mistakes? So I'm reporting, yeah, all the samples where my model had low confidence or something.
I mean, so there is this work in the realm of model cards where the idea is, you know, when you buy a dishwasher, it kind of says, this is the voltage, this is what you should expect. These are the circumstances under which it does work. Like, don't use it in an oven, like those kinds of things. So the idea is that people should maybe start writing these technical cards for models. Hugging Face has a little bit of that. And then you can say, like, look, this has been trained on Wikipedia, which is maybe a biased data set. So you can sort of warn people for that. But it's also become more and more normal to do this with data, such that a data set also has like a card attached where basically you just list all the things that you've tried to do to mitigate any bad things from happening, but still have like open concerns, so to say. I think this is one of the better practices that you could do in that sense. Like, just make sure there's like a fair warning label attached, just in case. But the reality mainly is, this is a paper that Google published. Even if you're not Google, there's probably one bad label in your data set. Like, that feels fairly likely to me. Unless on a daily basis you're meticulously trying to find bad labels, it feels easier for me to presume that there is a mistake than that there isn't one, simply because of the label errors website. There's so many bad labels out there. That's the best attitude, I think, to have.
What about having a process implemented where people can report bad labels so that you have multiple versions then of a data set and it gets better and better?
Oh, sure. That sounds sensible. But the gist of it is, but then still the attitude remains, there has to be some sort of attitude or process in place to just keep on working on the data quality. That's at the center and at the core. And of course, if you're doing this with computer vision or with text, it's kind of easy, I think, because a layman can typically say whether or not it's a photo of something or if the text is about a certain topic. For tabular data, this is way harder in general. You kind of need domain experts around immediately because of that. But with all the things that can go wrong in machine learning, I would argue that the earlier in your machine learning process where it goes wrong, the more damage that it can do. Therefore, if you fix your data, let's say you make a 1% improvement in the data quality, it might just result in a 2% model accuracy later on. That's kind of a feeling that I do have. But yeah, having like a weekly relabeling, new data came in, let's check for model drift. Those are all sensible things to do.
Okay, any other questions in the audience?
I have actually another one related on the process. Just thinking about another project we did, I think 1.5 years ago, where we had multiple annotators for a data set. And we tried there a bit. We had the problem that the annotators were not agreeing on many cases. So we tried to set up a very basic tooling, a process where the annotators in the beginning were randomly like labeling samples of others, or like relabeling, and then identifying cases where they disagree, and then make them talk. So have some kind of thread or chat or something. And I was wondering, like, what do you think about this? And particularly in the area of like research papers, data sets, where it's a lot of mechanical Turks just on their own. Have you seen any good tooling or anything that doesn't work?
So if you're interested in, so a couple of things to unwrap there. I do think what you did was a good thing. A couple of years ago, I was working at this one company, and something to do with auctions. And the idea was that this is a digital auction. So we really cared about the image quality. So also there, we had people annotate whether or not an image was of high quality, yes or no, which would feed the image classifier later. And these people would not agree. So the way that we dealt with that is, in the first couple of weeks, we said, we're only going to train on images where they do agree. And then after we've gotten a big enough data set of disagreement, then we're just going to get people in a single room to see if there's some sort of consensus that we can meet. The one thing that we learned there is that we had this one labeler who was very, very against this one label that was assigned to a photo, which later turned out to be a photo that he labeled a month before. So it's also the case that labelers change over time as well, which is something to keep in mind. Now, in terms of tools that people can use and that people can like, so do I have that here? So there is this thing I liked, if I'm doing something quick and dirty, there is this tool called Pigeon. Let me just copy that into my notebook. There we go. Did install. So while this thing is installing, this is basically like a lightweight classifier labeler thing that works inside of Jupyter. If the IPy widgets were, okay, I need to reload my IPython widgets, but normally if IPy widgets were loaded, this would bring up like a labeling interface when it's pretty basic and kind of works. For anything more general, I've used Prodigy in the past, kind of like that. And if you're using Rasa, I mean, at some point you want to have a labeling tool that's very specific to your use case. And the thing with Rasa, for example, is we're usually not dealing with like a single text at a single instance. We're dealing with text over a period of time, over a sequence of turns. So the more specific your use case, the more specific your labeling tools kind of got to be. But for basic classification, I can really recommend Pigeon. And for tabular data, you might want to check out Human Learn. That's also a project that has proven useful in the past for me.
Okay, all right, then thanks again for your presentation. And now let's come to the third part of today's meetup event.